Example, this is another question that asks us to do this without actually using a calculator. So the question is cos of 330 degrees, okay, multiplied by tan of 150, multiplied by tan of 150 degrees, okay, all divided by tan of 305 degrees. 315 degrees. Now, remember, you have to have foresight already, and foresight's telling me this is all going to work out to special angles, and then I can evaluate this without actually a calculator. But I'm going to tell you to avoid, to not think about the calculator too much right now. So let's simplify this. Cos of 330. If you've gone through the first set of videos, we spoke about the three nevers. We said never work with an angle greater than 360. Use coterminal angles to bring it within the Cartesian plane. Then we said our aim is to always reduce an angle to get it less than 90, and therefore we must apply the reduction formulae. And the third never, we said never, ever, ever, ever work with a negative angle. Okay? Always try and make it a positive angle by using coterminal angles once again. So let's start with the first one. Cos of 330 degrees, very simple. Cos of 330, there's a process here to simplify this. Firstly, is it greater than 360? No, so we don't need to find a coterminal angle with it. However, it's less than 360 but still more than 90 degrees. So we need to reduce this angle to bring it less than 90. So how we do this is we check where is 330, which quadrant is it in. 330 degrees, if I go to my summary sheet, 330 will lie in this quadrant over here. And the reduction formula there is 360 minus theta. Okay, so I've got this here, the quadrant is in the fourth quadrant. I'm going to say cos in that quadrant is positive, so it's positive cos, and it's going to work out to 30 degrees. Now, how do I get that? We have to solve for this angle, which I'm going to call theta, right? And you say theta, you say the given angle, which is 330 degrees, is equal to the reduction formula for that quadrant, which is 360 minus theta. Okay, so I say 330 is equal to 360 degrees minus theta. Now I say, therefore, theta must be equal to 360 minus 330 by solving that. And that's going to give me 30 degrees. And that's how I got positive cos of 30. Okay. So I'm going to simplify the very first one to say that that has to be positive cos of 30 degrees. Right. I want to go back to this thing over here quickly, and I just want to show you how some teachers may require you to write this, right? They may require you to use the reduction formula. So you say cos of 330, cos of 330 degrees is equal to positive, so cos in that quadrant is positive, so it's positive cos 360 degrees minus what will give me 330 minus 30 degrees, right? And now you say that's equal to positive cos when you reduce it, and whatever is here, our argument for theta, that goes there, and that's how I get that. Positive cos 30 degrees. That's how you simplify this. Teachers in grade 11 may require you to actually write this part out and then show us that that is 30 degrees. Okay, in grade 12, you don't need to show us this middle step. You can immediately go from 330 to 30 degrees, indicating that cos in that quadrant is going to be positive. Okay. So let's do tan 150. That has to be green. Tan 150 degrees. Tan 150 lies in the second quadrant because that's bounded by 180 degrees. So this is going to be in the second quadrant. We know that tan in the second quadrant is going to be negative, so it's negative tan. And then the reduction formula to solve for what angle goes in there, we say that the given angle, which is 150 degrees, must be equal to the reduction formula for the second quadrant, which if you go to your summary sheet, you can see it's 180 minus theta. So I put in 180 minus theta. And then I solve for theta, and I say, therefore, theta must equal to 180 minus 150, and that's going to give me 30 degrees. So your answer here is tan of 30 degrees. Now remember, in grade 11, some teachers may require you to write that as tan of 180 minus 30, And then they tell you, simplify it by showing that tan is negative. So it's negative tan. And then you take the 30 degrees and you put it over there. Okay. Now, why did I say 180 minus 30 and not 180 minus 150? Because this 180 minus 150 gives me the simplified version. I need to show that this over here is equivalent to that over there. And how have I done that? I said 180 minus 30, which gives me 150. I then use the 30 and I put it here, but I want to maintain the equivalent value, so I must indicate that tan is negative in the second quadrant. Okay, so this simplifies to negative tan of 30 in green, multiplied by negative tan of 30 degrees, all over tan of 315. Now guys, this one, pretty simple. Tan of 315 degrees. I'm going to do this one just by solving for theta without actually showing you the whole long thing that we have to write for grade 11, like this thing over here. I'm not going to do that. Tan of 315 is equal to 315 degrees is in the fourth quadrant, right? Which tan is negative, so it's negative tan. And 315, so I say theta, 315, the given angle is equal to 360 minus theta. Therefore, I solve for theta and I say theta must equal to 45 degrees, right? You can do that. I'm sure you can by now. And that's going to be negative tan 45 degrees. So over here, I'm going to have negative tan 45 degrees. Okay. At this point, because all of these things are special angles, I can immediately go and put in what I'm working with. Cos of 30 degrees is root 3 over 2, right, which is the same as sine 60. And then negative tan of 30, the equivalence of that is negative. Tan of 30 degrees is going to be 1 over root 3, or root 3 over root 3, root 3 over 3. So I'm going to put that as 1 over root 3, because that's a little bit easier. Divided by negative tan of 45, so that's negative. Tan of 45 is equal to 1, so it's negative 1. And now I say overall I've got negative divided by negative, which must give me a positive. The root 3 cancels out with the root 3, and I'm left on top with 1 divided by 2, which is 1 over 2, divided by 1. Remember, the positives and the negatives I've already worked out, and my final answer is a half. Okay, so that's the solution to this question.